There's this piece of technology that you've probably already used a dozen times today without even thinking about it. It is, quite literally, the hidden engine running our modern world. So, what do you think connects the silent, instant punch of an electric car off the line with the millimeter perfect grace of a factory robot? The answer is actually the same for both. Yep, it's the AC drive. It's this awesome combination of a really simple motor and a super smart electronic controller. It's the quiet, powerful workhorse that makes so much of our tech possible.
All right, so why this technology? Why has it become so dominant that it's basically everywhere you look? Let's dig into what makes it the go-to choice for engineers.
Well, when you look at the advantages, it's a total no-brainer. Compared to the old-school DC motors, AC motors are somewhere between 20 and 40% lighter. They're also cheaper to make. And the real kicker, they have way fewer parts that wear out, like brushes. That means less maintenance, less downtime, and just a whole lot more reliability. Okay, to really get this, we gotta dive into the heart of the machine, the AC motor itself. And the way it works is, it's both incredibly clever and surprisingly simple. It's really all about a chase. The most common type of AC motor is the induction motor. The easiest way to think about it is to picture a transformer, that transfers power wirelessly. Now imagine one part of that transformer could actually spin. That's basically it. You have the stationary part, the stator, and the rotating part, the rotor. And power jumps between them using nothing but magnetism. No physical connection needed. So here's the play-by-play in 4 simple steps. First, you feed AC power into the stator, which creates a magnetic field. Now, because it's alternating current, that field isn't just sitting there. It's actually rotating. This spinning magnetic field then creates a current in the rotor, and that makes the rotor want to chase after it. But here's the secret sauce, the part that's so cool. The rotor never, ever catches up to the magnetic field. There's always this tiny little gap in their speeds, and we call that slip. Now, that might sound like a bad thing, like a flaw, but it's actually what makes the whole thing work. That slip is exactly what generates the turning force, the torque. No slip, no power. It's that simple. Now, we've been talking a lot about the induction motor, but it's not the only kid on the block. The world of AC motors actually has a couple of different design philosophies. So you've got the workhorses, the induction motors we've been talking about. They're called asynchronous because, the rotor and the field are never quite in sync. Then you have the specialists, the synchronous motors. In these, the rotor is actually an electromagnet that literally locks on to the rotating field and spins at the exact same speed. Perfect for jobs that need incredibly precise timing. Let's zoom back in on that induction motor family, though. Even within this one type, you've got some really important variations, and it all comes down to how the rotor is designed. The 2 main flavors are squirrel cage and wound rotor. A squirrel cage rotor is super simple and tough. Its coils are all connected inside. It's a motor, and that's it. But a wound rotor is different. Its coils are connected to the outside through things called slip rings. And because of that, you can actually pull current out of it. That means it can work as a motor, or you can run it in reverse as a generator. Pretty clever. Okay, so we've got these motors that spin. That's cool and all, but how do we get that crazy precision we talked about earlier for something like a robot arm? Well, that's where the drive part of the AC drive finally comes into play. This is really the million-dollar question, isn't it? How do you take a motor that just wants to spin and turn it into something you can control with incredible finesse, giving it a whole range of speeds and torques? The answer is all in the electronics. The drive is the brain of the whole operation. Think of it like a sophisticated control panel. By precisely tweaking the voltage, the frequency, and the current going into that motor, engineers can make it do pretty much anything they want with amazing accuracy. And there are basically 2 main ways to do this. There's scalar control. That's the simple way. It just adjusts how much voltage and frequency you're sending. It's perfect for steady jobs, like a pump or a fan. But for the really high-performance stuff, you need vector control. This is way more complex. It controls both how much current you send and its timing, or phase. This is the magic that gives a simple AC motor the nimble, powerful feel of a high-end DC motor. It's why an EV can just leap off the line. So let's pull it all together. You've got a simple, tough, reliable motor, combined with a brilliant electronic controller. What does that actually mean for the real world? Well, it means this isn't some far-off future tech. It's happening right now. AC drives are actively taking over from the older DC drives pretty much everywhere.
This combination of benefits is causing a huge shift in how we engineer things, from factories to your kitchen. And if you just need one number to remember why this is all happening, here it is. Being up to 40% lighter for the exact same amount of power, that's a complete game changer, whether you're building a car, a drone, or even just a better power drip.
So in the end, it really is the whole package. It's the raw power of the motor, the incredible efficiency of its design, and that pinpoint digital accuracy you get from the modern drive controller. That's the trifecta. That's the reason the AC drive is the unseen but absolutely essential engine of our world. Which really just leaves us with one big question to chew on. We've seen them totally transform our factories and our cars. So as we keep pushing to electrify absolutely everything, what new doors are going to be unlocked by these small, smart, and incredibly powerful engines? What comes next?